Hello, today we're going to look at a problem where we're calculating out the differences between two populations to find out if there's a statistical difference between them. Now, specifically what we're going to be talking about is employees that exercise and employees that don't. So, we're going to be doing problem 9.4. Many companies have installed exercise facilities at their facilities. The goal is not only to provide a perk for their employees, but to make employees more productive by getting them into better shape. Infomatrix Software Company installed exercise equipment on the site a year ago to check whether it had a beneficial effect on the employee productivity. The company gathered data on a sample of 80 randomly selected employees, and the company found that of those 80, 29 worked out regularly, as defined by 3 times a week, either at the facility or at home. So the comparison was based on the employees' productivity over the year as rated by their supervisors. Each rating was on a scale of 1 to 25, with 25 being the best, and the data is on this next tab. It includes a yes-no column to whether the person is an exerciser and a column of ratings. And so we're going to create a side-by-side box plot to visually show the ratings by exerciser and non-exerciser, and then we're going to figure out, is there statistical evidence that exercisers are more productive than non-exercisers? So right off the bat, let's talk about what the hypothesis is. The hypothesis says that we believe that employees that exercise are in a better shape get a better rating from their performance. So that means the mean difference, and we are looking at exercise minus no exercise. If we look at that, that's going to be greater than 0. So basically the people that exercise will have a higher employee rating than the ones that don't, and so we will have a positive rating. So if positive, then exercisers perform better. If negative, then non-exercisers perform better. Okay, so let's go and look at our data, and then we'll test this hypothesis. So here's the data that we have, and truthfully, right off the bat, I want to make this box plot. I'm actually not going to make it in Excel. Let's go make it in Tableau, because it's going to look, especially box plots, look prettier in Tableau. So we're going to go File. We're going to go, actually this is already a file new. We'll go to Data Source, and we'll say, bring data from Microsoft Excel. And so what we want to do is bring in our exercise and productivity data. And so here we go. Here is all of our little sheets that we've got within the Excel. So I'm just going to drag over data and drop it in, and it's automatically going to populate the spreadsheet. Now you'll notice that we do have these columns for all this data here that we are using in Excel, that we've got listed in Excel, like the box plot, the question, and everything, that we're not really going to be using within Tableau, because it's all kind of not data that it wants. So I'm just going to hide all of that, because I just don't even want to see it. Yeah, and there's nothing in data 4 that we need, so we're going to hide that too. So it just leaves me with employee number, exerciser, and rating. And why do I do that? It's so when I go over here that I don't have all this extra stuff that I don't really need to look at. Okay, and so what we want to take a look at is we're going to look at rating and whether or not they're an exerciser. So I'm going to hold those two. I'm going to let Tableau show me, and the one I want is a box and whisker. And I bring that up, and I notice a couple problems with it. First off, it's just this one big thing of 2 data points. That's not what I want, because remember, Tableau does aggregate. So we're going to take aggregate off, and there we go. Now that's showing me each individual one. But it defaulted to put the exercisers on different colors. I actually want to take that and make them different columns. So now I have a yes exercise column and a no exercise column. And I do this once again, especially in the box and whisker plots. I just think Tableau knocks it out of the park on that. So if we sit here and look at it, well, what is our hypothesis? Our hypothesis is that the exercisers do better. And just looking at the box and whisker plot, the 50% between quartile 1 and 3, that's definitely seems to be a little bit higher than the 50% from 1 and 3 of the non-exercisers. In fact, the 75th percentile here is definitely higher. The average looks to be significantly higher. In fact, the quartile 1 of the exercisers is right about where the mean is for the non-exercisers. And so, sorry, not the mean, the median. In fact, the median is right at, because it's at 14, the lower hinge, which is quartile 1 on this, is at 14, so they're right there in line. So from this, just right here, kind of, at first blush, looks like that hypothesis that we're making is what we expect. But we need statistical data, because we can't just say that based on visual anecdotal evidence. We actually have to show the numbers are going to bear it out. So what I'm going to do, because we're going to be doing a lot of statistical equations, let's make our range names. And so I am going to create from selection. Now watch out, this is Word, so it's trying to do both left column and top row. We just want the top row. And then over here, I'm going to grab all of these ones and give them range names. So create from selection from the left column. It's getting confused because there's words here, so it doesn't know where it wants to pull it. There we go. Now we've named everything. So we're going to do a one-tailed analysis. We're looking greater than, because we're making the assumption that our difference is going to be greater than 0. Because that's the hypothesis we're testing. If we were saying that the ones that didn't exercise did worse than the ones that exercised, we would have flipped our mean around, and we'd flip around our analysis, because we wouldn't be looking for greater than, we'd be looking for less than. But we're doing right now greater than, because we want to say that everybody's doing better. So the first thing we need to do is go to our sample size. So we're going to use Countif, because we've got a couple of different things within that column, and we're going to do the range, and we already named that, and that first range is exerciser. So we'll hit that, and you'll see that over here it all pops up blue because we've already named it. And the criteria is category 1, which is going to be a yes. We'll close that off. 29 people exercised, which if we go back here, that matches what they told us that it was going to be 29. Okay, so sample size 2, we're going to do the same thing. I'm just going to drag that down, change this to category 2, and everything lights up the way it should. That's my category 2. 51 that did not exercise normally. Okay, we need to find our sample mean. Now, we have both exerciser and non-exerciser mixed up in this column. So what we're going to do is we're going to use an average if statement that allows us to average things of a certain criteria. And so the range, we're going to be looking at the range of exerciser. And the criteria is going to be category 1, so that yes or no. And then what we're going to average is that rating column. And so once again, all named in there, all taken care of. So our sample mean is a 16.86. And then we're going to do it for our second one. All we have to do is come in here and change this to category 2, because we already have it named, and there we go. So the mean is slightly lower, 14.14, and so now we're going to do the sample difference between those. So sample 1 minus sample 2. Now that tells us that on average the mean is 2.72 higher on the exercisers than the non-exercisers. So now we have to do the standard deviation. So stdev.s for the sample. Now remember, we're in a situation where we don't have a standard deviation if statement, so we're going to have to kind of do this workaround, and we're going to write an if statement. And so the if statement is going to be exerciser, which is that first row of data, first column of data. If exerciser is equal to category 1, and then we're just going to end it. Actually, no, we're not going to end it. We're going to say rating. That's right. Value of true. Value of true is going to be our rating. We don't have to put a value if false, because value if false, it just won't put anything in. And so we're going to close that up. Now, remember, this kind of fakes out and makes it a standard deviation if statement. If I just hit enter, I get a divide by zero error because in some of those ratings, I'm going to have zeros. We need to do an array calculation. You're going to hold control. You're going to hold shift. You're going to hit enter once you're in the control shift enter. And now we've got the little brackets. Brackets say that we're running an array equation. We are doing good. Now remember, if you are up in there working that and hit enter again, it will de-link it as an array equation. So control shift 0. Anytime that you're playing with that equation, make sure you do control shift enter. These are draggable, which is great, so we're going to drag it down for standard deviation 2. I'm going to go in, I'm going to do the change here to category 2. Once again, if I just hit enter, it's not going to work. So control shift enter, and there we go. So I have my standard deviation from the second one using this array function. All right then, so where we're going to go is we've got to put together our pooled standard deviation, and this is our big long equation from our notes. So let's get to it, and that's going to be the square root. So it's the square root of sample size 1 minus 1. And then we're going to take that now. We need to sneak another parentheses in there because I'm taking the square root of everything that we're going to write. So I take my sample size minus 1. I'm going to multiply that by my standard deviation of that sample. And we're going to square that. Okay, and then after that, we're going to add to that our sample size 2 minus 1. It's basically the same thing. We'll put parentheses around there to make sure that works. And then we're going to multiply that by the standard deviation of 2. And we're going to square that. And so then what I want to do is I want to take all of this that we just typed in. So I'm going to put in another parentheses there. I'm going to take all of that and I'm going to divide it by the degrees of freedom. And so in this case, that's going to be sample size 1 plus sample size 2 minus 2 because we've got the 2 sets of data. I'm going to close the parentheses around the denominator, close it around the whole square root. I'm going to hit enter and hope it all works out. And that is what I wanted to get. My pooled standard deviation is 4.909. And with that, I'm going to end part 1. Part 2, we'll just sit there and finish off this question.